Qubit, set a course. I want to visit that bright blue star we keep flying past.
Ooh, excellent pick, though I should warn you, it's a fair distance.
How far are we talking?
About 10 years of flying to get there and 10 more to come home.
20 years. I'd come back practically grown up, and everyone at home would have moved on without me.
Here's the wonderful part. For you, it wouldn't be 20 years at all.
What do you mean, not for me?
Fly fast enough and your own clock quietly slows down. You'd step off barely older.
While everyone back home ages the full 20 years?
Every single one of them. You'd return younger than friends who never left.
That's not how time works, Qubit.
Last time gravity bent your time. This time, all it takes is speed.
Okay, prove it. Vega and Qubit, and the twin who came back younger.
You already know time isn't the same everywhere. Last time, gravity was the culprit.
Right? Deeper gravity, slower clock.
This time there's no heavy thing at all, just plain, ordinary motion.
Just moving is enough to bend time?
The rule is beautifully simple. The faster you move, the slower your clock ticks.
Slower compared to what, though?
Compared to everyone you're moving past, that's the whole trick of it. To them, your clock runs slow. To you, everything feels perfectly normal.
So I'd never actually feel my own time slowing.
Never. A second always feels like a second from the inside, exactly like last time. The difference only appears when you compare your clock against theirs afterward.
Then why have I never noticed this on, say, a fast train?
Because at everyday speeds, the effect is almost unimaginably tiny.
How tiny is tiny?
A whole lifetime on the fastest trains would slow your clock by less than a single blink.
So it only really matters when you go fast, fast.
Cosmically fast, a serious slice of the speed of light.
And how fast is that?
Light crosses 300,000 kilometers every second, the fastest anything can go.
Nothing beats light?
Nothing with any weight even matches it, and the closer you creep toward it, the more your clock crawls.
So speed and time are secretly linked.
Two sides of the very same coin. Spend more on speed, and time gives you a discount.
Has anyone actually caught this happening?
Back in 1971, scientists flew super-precise atomic clocks all the way around the world.
And?
The flying clocks came back a hair behind the ones that stayed on the ground.
The moving clocks literally lost time.
Exactly as predicted, and nature runs the same experiment over our heads constantly.
Over our heads?
Tiny particles called muons rain down from the upper sky, and they're extremely short-lived. By rights, they should fizzle out long before they ever reach the ground.
But they make it?
Floods of them do, because they're moving so fast their own clocks barely tick.
So their short little lives get stretched just by going fast.
Stretched enough to finish a journey they could never otherwise survive.
And that's happening right now, above me?
Right now, all day, every day, time dilation falling like a gentle rain.
Okay, I believe it's real. But does it ever touch normal life?
Remember the map satellites from last time?
The GPS ones, whose clocks run fast up high.
Those same satellites also lose about 7 millionths of a second a day, purely from their speed.
So gravity speeds their clocks up, but their speed drags them back down?
A tiny tug of war in every satellite, and last time's number was already both effects combined.
The two halves of the very same story.
And your phone quietly accounts for both all day long.
So I've been carrying speed-bent time around in my pocket this whole time.
Everyone has. It's the quietest piece of physics in daily life.
Okay, take me back to me coming home younger.
This is the famous one. Picture two twins, exactly the same age. One blasts off toward a distant star at nearly light speed. The other stays home.
And the traveling twins' clock runs slow the whole way.
The entire trip, so when the traveler finally comes home, only a few years have passed for them. But back on Earth, whole decades have rolled by.
So they were born the same day, and now one of them is way older than the other?
The traveler steps off the ship still young to greet a twin grown old.
That's the most beautiful and unfair thing I've ever heard. But wait, couldn't the traveler just say they stood still and Earth flew away instead?
Now you're really thinking like a scientist. That's the classic riddle. If all motion is relative, why is the traveler the younger one?
Right, it feels like it ought to be a tie.
The tiebreaker is the turnaround. Only the traveler has to slow, stop, and fly back.
And that turn is what breaks the tie?
That turn is the whole difference. Only one twin truly changes course, so only one comes home younger.
So it's genuinely real, not just a clever story.
As real as physics gets, the traveler truly skips ahead into everyone else's future.
Time travel, but only forwards.
Forwards only, and never back. The future keeps whatever you skip over. And humans have already measurably done this.
Real people?
Every astronaut who's orbited Earth has come home a sliver younger than they'd otherwise be.
Because the station is moving so fast.
Zipping around the whole planet many times a day, fast enough to nudge their clocks.
So how much younger are we talking?
One cosmonaut spent so long in orbit that he came back about a 50th of a second younger.
A 50th of a second, that's it?
Tiny, yes, but it's a genuine measured trip into the future made by a real person.
So the twin story is really just this, turned way, way up.
Turn the speed up near light and a 50th of a second stretches into years.
We just can't fly anywhere near that fast yet.
Not yet, but the physics is already sitting there, waiting for a fast enough ship. And let me be honest with you. At the speeds we travel today, it's all still whisper small.
So I'm not out-aging anyone on a normal flight home.
Not in any way you'd ever feel. It takes the universe's finest clocks to even catch it.
But near light speed, it stops whispering and starts shouting.
Let's climb the speed ladder, gentlest first. A car on the highway, no change you could ever hope to measure. A jet across the ocean, clocks slip by mere billionths of a second. A space station, fractions of a second over a long mission. A mun from the sky, its short life stretched many-fold. And a ship near light speed, where years out there shrink to mere days aboard.
One quiet rule, running from a parked car all the way to a starship.
And here's what I love. Put this together with last time. Where you sit in gravity bends your time, and how fast you move bends it too.
So my clock is set by both where I am and how fast I'm going.
Which means, just like last time, there's no single clock the whole universe shares.
Just my now, your now, and the traveler's now, each moving at its own pace.
And every single one of them completely, honestly correct.
So if I really did fly out to that blue star and back,
You'd come home barely older to a world that had lived a whole 20 years.
I'd be time traveling into everyone else's future.
Just by going fast enough, the universe's strangest, truest kind of travel.
So would you actually do it? Fly out and skip ahead?
Only with the right co-pilot, and I happen to have one.
Wait, if going fast slows time, what would light itself feel?
Oh, now you've found the deepest question of them all. Next time, for a beam of light, no time passes at all.
Light doesn't age?
From light's own point of view, it's born and it arrives in the very same instant.
Okay, that one's going to keep me up for a week. If part of you now wants to fly into the future, same. Subscribe so you don't miss it.
Plotting our fastest course yet.
See you out there, explorers.